record. Okay, record. Okay, perfect. It works. Now I'm gonna share the board, and I hope it's gonna work. Share the board. Okay, here. Okay, perfect. Here's the board, and let me. Okay, here's the board. Here's the chat. I need to see the chat. Okay, perfect. So, guys, so I was saying. So we're gonna continue with the section. So this is a section 2.1. And actually, I'm going to combine section 2.1 and section 1.4. So this is also section 1.4. Okay. Again, it's about tangent lines and, of course, derivatives, the definition of derivative, some derivatives. Okay, so thank you for the quick tip. So as I said last week, I introduced this notion of tangent line. I guess I tried to motivate them the definition, but probably I gave just one example. So let me remind you the definition. All right, and I'm gonna do probably one more example. All right, and then we can practice, with more with exercises. So first, let me just remind you this definition of a tangent line. So, so we said, so tangent line, we said, I mean, the main motivation about the tangent line is that the tangent line would be like a best, the best linear function that would approximate the function f of x in a small neighborhood of the point A, right? But then what's the, I mean, the definition, the definition of the tangent line is the following. So the tangent line, it's a line, it's called a tangent line, so it's a line. So the tangent line to the function f, so to f of x at the point x equal to a, right? So it's a tangent line, so it's a line, so is the line, right? Passing through the point a, passing through the point a f of a, f of a. Okay, so it passes through this point a f of a, and with the slope, so the slope of this tangent line is given by, so m equals to the limit h going to 0, f of a plus h minus f of a over h. Okay, so this is the definition of the slope of the tangent line. And so we said, I mean, in practice, we're gonna use, of course, we're gonna use this definition here. So we're gonna use this, right? Use this definition, right, of m. But actually, this definition is equivalent to the following. So it's equivalent to m equals to, so it's the same definition. I mean, you get the same answer. So it's m limit x going to a, f of x minus f of a over x minus a, right? Again, it's the same definition because all you have to do is just replace x by a plus h. So replace x by, so x, if you replace x by a plus h. So for example, f of x would be f of a plus h. So we see here, f of x would be f of a plus h because we said x, we're going to replace x by a plus h. Here, x minus a, I mean, if x is a plus h, then a plus h minus a would be h, right? And if x approaches a, if this x here approaches a, well, then this h would go to 0, would approach 0. But anyway, so these both of the definition are the same, so they are just equivalent. And as I said, the idea behind this tangent line is that that's the best linear function that approximates the function f in a small neighborhood of a. So we said, so the idea is the following. So we said, so the tangent line would be the best approximation. So the tangent line would be the best linear function, right? That approximates f of x, in a small neighborhood of a. And I think last time I gave an example. I explained why this would be like the best linear approximation of the function f. But anyway, probably going to do more examples. So that approximates f of x in a small neighborhood of a, x equal to a. X equal to a, right? But anyway, so before the examples, guys, so this is just to remind you the definition, but before the examples, let me write down for you the equation of the tangent line. So, oops. So the equation, what this means. Next slide. Well, I have already premium account. Okay. Oh, okay. Nope. Anyway, so probably I'm gonna go down here. Anyway, so so I was saying, so the equation of the tangent line is the following. So here's the equation of the tangent line. So we said the equation is the following. We said it's actually y. It's a line. So remember, guys, the equation of lines are equations of lines are of the form like y equals to ax plus b. So a would be like the slope, right? So ax plus b. So the equation of the tangent line is actually y equals to m. So that's the slope times x minus a plus f of a, right? So this is the equation of the tangent line. So that's the equation of the tangent line to f of x. So this is tangent line to f of x at x equal to a, right? Okay, so that's the definition. So let's have a couple of examples. Okay. So examples. Okay, so let's take the following example. So let's say f of x equals to, so again, guys, please, if you have, if you have any question, don't be shy. Please feel free to interrupt me and ask a question, right? So, so here's an example. Let's say f of x is equal to x squared minus 1, right? So what we're gonna do, we're gonna try to find find the equation of the tangent line to the function f at x equal to 2, right? So when I say x equal to 2, it means that, so my a is actually equal to 2, okay? So my a is 2, my function f is x squared minus 1, all right? And so let me, okay, so let me just probably graph this function f, and so we can visualize what will be the tangent line. Let's see here. So tangent line to f of x at x equal to 2. So let's say you have, so here, let's say we have our graph. All right, so I'm gonna graph x squared minus 1, right? So this is, let's say 1, 2, 1, 2. And let's say probably I'm gonna need 3, so here's, okay. So here, let's say 3. All right, so here it's -1, this is -1, and here in the bottom it's -1. But anyway, so if you're gonna graph x squared minus 1, so for example, if x is 0, so then f of 0, so for example, f of 0 would be, -1, 0 squared minus 1. F of, again, f of x is, we said it's x squared minus 1, right? So f of 0 would be -1. F of 1 would be 0. F of 2 would be, 2 square, 2 square minus, 2 squared minus 1, that would be 4 minus 1, so that would be 3, etc., right? So anyway, so if you graph f of x, so we're going to have the following graph. So here's a 0, 0, -1. This is 1, 0, right? And here's 2, 3. We're going to have -1, 0 here, and probably -2, 3 here. Anyway, so here is the graph of x squared minus 1, sorry. So this is your graph. So this is f of x equals to x squared minus 1, right? So so we wanna find the equation of the tangent line of f of x at x equals to 2, right? X here is equal to 2. So first thing in the definition, guys, we said, a tangent line to f of x at x equal to a, to the number a, is the line passing through the point a, f of a, right? So here you see this is the point f of a, right? So the line passes through the point a f of a. So here a is, in this example, a is equal to 2, right? So a here is equal to 2, right? That's my number a. So here is my number a. So what will be the point a f of a? So f of a, f of 2 is c, right? So here's the point a f of a. So this is my point a f of a, right? This is a f of a. So, or 2 f of 2, which is f of 2 is 3, right? So that's the point 2, 3 right here. So it's 2 here, and then 3 here, right? So we said by definition of the tangent line, it passes through the point a f of a. So in our case, a is 2, so it's gonna pass through the point 2, 3, right? So it's gonna pass through this point 2, 3 here, and so here. So let's say here, this would be our tangent line. So this would be our tangent line. Okay, so to f of x at x equal to 2. But of course, we need to compute the slope of this tangent line, right? So, to compute the slope, of course, we have so we have to compute our number m, right? That's the slope. We said the slope of the tangent line would be this number m, which is which is the limit of f of a plus h minus f of a over h. Anyway, so let's find the equation of this tangent line. So first step, so step one. So if you want to find, so here, what we are doing, guys, we're gonna try to find the equation of the tangent line, right? We'll find the equation of the tangent line to f of x, right? To f of x at x equal to 2. So step one, we need to find the slope m of the tangent line. Find the slope m, right, of the tangent line. So m would be equal to, so m by definition is limit h going to 0 of f of a plus h minus f of a over h. All right, so this is a definition of the slope of the tangent line. So in this definition, we need, of course, we need f. Well, we know our function f is the x squared minus 1, right? F of x is x squared minus 1. We need a. A we said is equal to 2, so a is equal to 2. And then f of x, so f of x is x squared minus 1, right? So anyway, so in this definition first, I need, so you need, we need, you see here, guys, we need f of a plus h. So that will be a is 2, right? So we're gonna need f of 2 plus h. So we need, first we need to find f of 2 plus h, right? So, so I'm gonna compute f of 2 plus h. F of x is x squared minus 1. So you see, guys, here x, you replace x by 2 plus h. So this x here would be 2 plus h, right? So this is here, this would be 2 plus h, and there's a square, and then there is minus 1. So this is, so f of 2 plus h so that would be 2 plus h squared. So the circle, think of the circle like parentheses. So that's 2 plus h parentheses, and then square minus 1, right? Of course, you can distribute this 2 plus h squared. So it's like, f of 2 plus h, it would be like 2 plus h times 2 plus h minus 1. So we have to distribute, right? So let's distribute and then simplify. So f of 2 plus h would be, so 2 times 2 is 4, right? So this 2 here times 2 is 4. This 2 here times this h, that would be plus 2h. So it's plus 2h. And then we have h times 2. So this h here, so this h here times 2, and then h times h, that's h squared. So we're gonna have plus h times 2, so that's another 2h plus h squared, and then minus 1, of course. All right, so that's my f of 2 plus h. So now if you simplify, so you see, guys, we have 4, the constant. So we have here 4 and minus 1. So that will be 3, right? So here's the 3 plus. Now, how many h's do we have? Well, we have plus 2h plus 2h. So you see here, This is plus 2h here, plus 2h. So that will be plus 4h, right? And then there is h square left, right? This h square here. So that's my my plus h square. So plus h square right here. All right. So that's f of 2 plus h. All right, so that's the first thing to compute here. That's this f of a plus h. Next, in the definition, I need f of a, right? So I need my f of a. F of a, I mean, a is 2. So then f of, I need to compute f of 2. So this is, again, this is f of a. So that will be equal to the function f is x squared. Here's my function f, right? X squared minus 1. So that's, of course, 2 squared minus 1. So that's 4 minus 1. So that's equal to 3, right? So f of a, or f of 2, is equal to 3, right? So now I have all the ingredients to compute my m, right? I have my f of a plus h. I have my f of a. And then I have to compute the limit, right? Now I have to compute the limit. So let's compute this limit. So now we can compute m. So m would be the limit, h going to 0. So first we said f of a plus h. So that's f of 2 plus h. And here's my f of 2 plus h, right? That's my f of a plus h. So we have 3 plus 4h plus h squared, right? So that's my, that's my f of a plus h, right? Now next, we need minus, there's this minus here, minus f of a, so, or f of 2, right? My a is 2, so minus, now we need minus f of a. So minus f of a is, it's f of 2, which is 3, right? Here's my f of a, which is f of 2, which is 3. So here it's minus 3 here. And the whole thing, of course, divided by h. So we need to compute, this would be the slope of my tangent line. Again, the tangent line passes through the point, our point 2, f of 2, which is 3, right? At the point 2, 3. So let's compute this limit. So first, here we can cancel out this 3 here, 3 minus 3, right? And then we can also, so let me just write it down for you here. So the m would be limit h going to 0. So 4h plus h squared over h. So that will be, so m is, now you see guys here in the top, h is a common factor, right? So we can factor out h. So this is limit h going to 0. We can factor out h. So that's 4. H times 4, that would be 4h. And then this h squared. So if you factor out h, so we're going to have h, right? So it's h times h and over h, right? So we factor out h because h is a common factor. So now I can cancel out this h here in the top with the h in the bottom, right? So we're almost done. So then my slope, m would be the limit h going to 0, 4 plus h. Right, so now I simplified my expression. So now I can evaluate the limit. So I can just plug in 0. So my h is supposed to be 0, right? So here h is supposed to be 0. So then that will be 4 plus 0. So that will be equal to 4. So the slope of my tangent line to the function f of x at x equal to 2 is actually equal to 4. Right?
Professor,
yes.
Why is the limit h going to 0?
Yeah, because well, first that's because, well, that's by definition of the definition of this slope here. You see here this um, uh, So this h, you see this h here in the definition, right?
Yes.
So this h going to 0, it means that actually x approaches a. You see this here, x is supposed to be equal to a plus h, right?
Yes.
So if h is 0, if this h here is 0, then so what I'm doing is my x is actually approaching a, which means in some sense I am like in a small neighborhood of a. That's why my h goes to 0, because my x. So as I said, remember when I said the definition of the tangent line, I said it's the best. It's supposed to be the best linear approximation of the function in a small neighborhood of a, right? So if you are in the small neighborhood of a, so what you do is you need to approach. You are very close to a, so you're gonna approach your x, the values of x, they're gonna approach a. And if the values of x is gonna approach a, so that's exactly our definition here. You see the second definition I gave for m.
Yes.
Here for the second definition, I said x going to a, and I said that would be equivalent to this to the limit with h going to 0. But this second definition here, this one here, you see my x is going to a. That's because I need my approximation to be valid in a small, very small neighborhood of a. So I need to approach a, as close as possible. So that's why h is going to 0. So because I need to, my x, the values of x, they need to go, they need to approach a. It's just, I mean, again, the two definitions are equivalent. You can work with this x going to a instead of the h going to 0, but both are actually equivalent.
Okay.
Okay. So where is it? Here, my h going to 0. And again, guys, so what you need to keep in mind is that this notion of a derivative, it's really about the behavior of the function f in a small neighborhood of the point. Okay, I mean, you don't really care what happens like if you are far away from the point. Okay, what's really important is what happens like in very, very small neighborhood of the point, right? So your values of x, they are supposed to be very, very close to a, because the derivative is supposed to describe, and we're gonna see, I mean, after probably the next section, we're gonna see like many interpretations of the derivative, and it's all about the behavior of the function in a very small neighborhood of the point. So that's so again, that's why your x is supposed to be very close to a. So that's why you need your x to approach a. And the equivalent definition would be with this h going to 0. All right. So the h, you can think of h like the distance between x and a. So if you want to approach, if you want to be in the small neighborhood of a, you need the distance, this h, this difference between x and a, to approach 0. Okay. So you can think of this h like the distance between your x and your a. And again, we'll see later. I mean, this derivative thing is just about the behavior of the function in a small neighborhood of the point. Anyway, so we got 4 as a slope, and so then the next step would be to then we can find the equation of the tangent line. So we are I guess the first step is the hardest step, because the step number 2 is just, sorry, so step number 2. So the step number 2 is, so we can find now the equation of the tangent line. So we said, I mean, the general formula is the following. So it's supposed to be y, so this is the equation of the tangent line, of course, the tangent line. So again, it's supposed to be y equals to m times x minus a plus f of a, all right? So you know from step one, you know that m is 4, right? And I mean, it's given in the problem. So a is supposed to be equal to 2, right? X is equal to, the equation of the tangent line to f of x. So here, to f of x at x equal to 2. So a is supposed to be 2. So here a is supposed to be 2, right? And so what's f of a? F of a, we said that would be f of 2, and we said that would be equal to 3, right? 2 squared minus 1, that would be 3. So anyway, so that's, so here's our equation then. So that would be y equals to m is 4, right? Then x minus a is 2, plus, and then you have f of a, which is f of 2. So f of 2, it's of course 3, right? So we can simplify here. I guess we can distribute at least. So y would be 4x minus 8 plus 3. So y would be 4x minus 5. So this is the equation of the tangent line to the f of x at x equal to 2. And again, I think I did this last week, but I mean, we can check that. Of course, this is, this is the equation of a line, right? Like if you have ax plus b, that's the equation of a line, right? This is ax plus b, right? You have 4x minus 5. So this is the equation of the tangent of a line. And so we said, again, the motivation is that this line here, or this linear function, it's the best linear approximation to the function f around in a small neighborhood of a equals to 2. Anyway, so that's for the equation of the tangent line. So here's an exercise, guys. Unless there's a question, or is there any question? Or so the definition is really important, actually. I mean, in the whole chapter, all we're gonna do is just computing limits. I mean, derivative. It's derivative is about limits. So so you need to you need to memorize, of course, this definition of the derivative. I mean, this is the slope here, m, which is this limit h going to 0. As I said, actually, we have two equivalent definitions of this slope m, right? The first with h, first definition with the with this h going to 0, or we have also an equivalent definition with x going to a. But as I said, in practice, it's better to use this. It's easier, I think. The one with h going to 0 is easier than the with x going to a. All right, but anyway, actually, both are the same. Okay, so here's the exercise, guys, where we have to find the equation of tangent lines. So exercise. So, oops. Exercise. So you need to find the equation of the tangent line. So find the equation of the tangent line to, well, first, f of x equals to square root of x, right, at x equal to 1. Number 2, f of x equals to sine of 2x at, so you need to find the equation of the tangent line to this function f at a So x is equal to 0. And last one, f of x, say, equals to x cubed at x equal, let's say again, 1 here, x equal to 1. All right. So all you have to do, guys, to find this equation of the equation of the tangent line is, to follow these two steps, right? So first step, step one. So you see here, step one, we said you need to find, here's step one. You need to find the slope of the tangent line, right? So we have this m equals to limit h going to 0, right? So so first, that's the first step. We need to compute this limit here, h going to 0 of f of a plus h, etc. And then the step number two, well, we are almost done actually. In the step number two, you have your, the general formula of the tangent line here, and all you have to do is plug in numbers, and you're gonna get the equation of the tangent line, right? So anyway, please try to find the equation of the tangent line to these functions here. Of course, a would be this number here. So like for number one here, this is your a, here's your a, and here's your a. So I'm going to give you probably 5 minutes, guys, to think about this exercise. Again, it's about computing limits. So you have to find first this slope m, and then you can write down the equation of the tangent line. I'm here, guys, if you have any question. Um,
Professor, can you scroll up a little?
yeah, sure.
I just want to see the last problem. Okay. Wait, so yeah, this is Professor, I don't get that. Find the equation with tangent line at x equals 2. How did you get m to equal 4?
Oh, that's from the m equals to 4. That's from the step 1. That's
Mm-hmm.
from this step here. You see this here, this m here.
Okay.
Yeah, we got 4 here. That's from the first step. That's why m is 4. That's from the when you compute the limit, right? They compute this limit
Oh,
here,
okay, okay.
right?
All right.
That's really weird. I mean, it says like if I want to move to the next page, I need to get like a premium account, but I do have one already. I mean, that's my premium account. I don't know. Uh,
Professor, the first one, y equal to 1 over 2 x minus 1.
1 over 2x minus
1 over 2.
uh,
1 over 2x minus 1 over 2.
Yes, the 1 over 2 is correct. The slope is going to be 1 over 2, and then so it's minus. No, I think it's plus. It should be plus
Oh yeah, plus.
plus.
Plus 1.
Yeah, it's supposed to be plus something 1 or 1/2, 1.5. Um, Uh, yes. So no, sorry. It's a plus. It's a plus 1/2. Yeah, plus 1 over 2. I think
Yeah.
plus 1 over 2. Uh, Moses, you're saying, oh yeah, look back. Yeah, so that's what I'm gonna do. But I'm just scared that I lose my. So I'm gonna, I'm gonna download this page because I don't want to use the page. So here. Okay. So let's duplicate here. Has been saved. Okay, perfect. Okay. So I'm gonna log out. Sorry guys, I mean, I'm gonna log out and log in again. Okay, start drawing, sign up. Okay. Okay, yeah, it works now. It works now, but of course, I think okay, I can write down probably the exercise again. Thank you, Moses. That's the right thing to do. Yeah. Exercise. So we said, so first we had square root of x at x equal to 1. And then we said sine of 2x at x equal to 0. And then we said, I think x cubed, if I'm not mistaken, at x equal to 1. Any guess for number 2? Oops. And of course, okay, let me write down here's the question. So find equation of tangent line. So we're gonna see, guys, this slope m. The slope m has a name, so that will be actually the derivative of the function f at the point A, right? Um, And the slope m actually has many interpretations. So we're going to see a couple of interpretations. For example, in physics, if we have like a particle moving along a path, right? So that the number m, the m would be the velocity of the particle, or I mean, if you, in other words, that would be the speed of the particle, right? So this number m, the slope m, has so many interpretations in physics, and you know, so it's so that would be the number m would be the derivative, actually the derivative of the function f at the point A. So like in physics, if you have like if you are taking a physics course and you're studying like velocity or acceleration of particles or anything, so always you in physics you always think of the derivative as the speed or the velocity, right? And actually we'll see, like if you compute the second derivative would be like the acceleration of the particle, all right? So yeah, anyway, so all I'm saying is this definition of m, the slope m is it's actually a very natural, it's a very natural quantity. It's not something that artificial. Okay, guys, I'm not sure if you are done with the.
Can you give us 5, 10 more minutes?
Okay.
Thank you.
No problem. And actually, if we want to be precise, this number m, I mean, in physics, would be the instantaneous velocity. Is so it's the velocity at the instant, like t equal to a at x equal to a. So
Y equal to 2x, or the number 2.
y equal to 2x. So let me think about it. So it's yes, and yes, and yes. Y is equal to 2x. Very good, Ibrahima. Yes, absolutely. Very good. Yes, very good. I think in the homework there are probably, I think, two problems about the tangent line. I mean, it's similar to this exercise, I think, if I'm not mistaken. Yeah, actually,
Professor,
yes.
I'm getting stuck on
Number one.
yeah, number one, because I'm not quite sure how to do the square root. I'm following the formula, I'm following the procedure, but when it comes to the limits, I'm not really sure how to
So,
solve it.
okay, so what's the so what will be the definition of m? So what will be your m? So it's limit h going to 0. So what do you have in the top?
So at the top, you would have let me check my notes. At the top, you would have yeah, the top you're going to have f a plus h
Mhm.
subtract f of a, and yeah, for the yeah, I know that for the top you would have a and a plus f a plus h, and f a plus h. What I got was going to be square root of 1 plus h subtract 1
That's correct.
over h. Yes.
That's correct. That's very good. And so now you can see if you let's just you plug in 0. I mean, if you replace h by 0, you're gonna have 0 over 0, right?
Yes. Wait, wouldn't you have negative 1 over 0?
No, we have we said we have you said you have a square root of 1 plus h,
Yes.
and then there's minus 1
Yes.
on the top over h.
Yes.
So if h is 0, so that will be square root of 1 minus 1. That will be
Uh,
0.
yeah.
0 in the top and h is 0, so 0 in the bottom.
Uh-huh.
That's 0 over 0, right?
Yeah.
So so in that case, remember if you have a square root, then we would multiply by the conjugate, like multiply by the
Oh.
square root of 1 plus h plus 1.
Oh,
Remember
okay.
that? I mean, when we did the limits with the square root.
Yeah, okay, I remember. Yes. So
Yeah.
multiply by the conjugate. Yeah, that's
Yeah.
true.
Conjugate. So actually, we have to apply all the things we learned about the limits in this with this derivative.
So, Professor, so isn't it step one the final answer 0?
For the first function, the number
Yeah.
one,
Yes.
nope, it should be half. It should be half final answer for step one.
Mm.
Okay, so I guess, yeah, well, I'm gonna, so let me do it, all right? So, okay, so this is for number one.
Because for some reason I followed the steps, but I got 0.
So
I don't know.
what was your age?
Um. So my age was 0.
What was 0? And what's your M? Sorry, I meant M. What's your M?
Okay, so yes, my M was 0 and my A was 1.
Okay. Yeah, so M, M is wrong, of course. But so what's the expression? So what's your limit? What was your limit?
Um,
The limit is going to 0
my limit was going to 0,
of what?
and then I had, so from here I got 1 plus 1 age. Well, 1 age times 1 age minus 1.
No, I don't. No,
I don't know.
no. I think it's no. I think it's not correct. Okay, so let me explain. Okay, here's a step one.
Okay.
Okay, so here's the definition. So M should be limit h going to 0, f
Mhm.
f of a plus h. So a is supposed to be 1, right?
Yes, correct.
F of 1 plus h minus f of a. My a is 1, so it's f of 1 over h.
H.
Okay,
Mhm.
now the problem is, so you want to compute, so first you need to find f of 1 plus h. So the question is, what's f of 1 plus h? So this thing here, what's f of 1 plus h? What do you think would be f of 1 plus h?
1.
Square root of 1 plus h.
Yes, square root of 1 plus h. It's not square root of, it's not square root of 1. It's, you see, it's f of x is square root of x, right? Now
Okay.
you want to compute f of 1 plus h. So you see, instead of x, instead of this x,
Mm-hmm.
you have 1 plus h. So whenever you have x, you have to replace it by 1 plus h. So you see this x here?
Mm-hmm.
You replace it by 1 plus h. You have the square root. Okay, so you have this, we have the square root, so we have the same here, square root. But then this x, instead of x, we're going to have 1 plus h. So we're going to have 1 plus h. You see what I'm saying? It's, you just plug in 1 plus h instead of, instead of x.
Okay. I have that.
Okay, okay, perfect. So then, okay, so that's the square root of 1 plus h. That's perfect. Now, you need, and then you need f of 1, right? This f of 1 here. So let's compute f of 1. Well, f of 1 is just, square root of f of x is square root of x. So f of 1 would be just square root of 1, right? Which is, of course, 1.
Okay.
Okay, so what I'm saying is this is here 1, and here this is square root of 1 plus h.
I think what I did wrong is I wasn't writing it in the square root. I was just going like
Wait,
putting it in parentheses instead of putting it in the square root.
Okay, so yes.
Professor, why do you expand the square root to be over h?
Uh,
Because I've noticed you put the square root over the h2 instead of just 1.
where? In the,
Yeah, f1 plus h equals square root over 1 plus h.
no, I don't have that.
Because it looks like it's over the h also.
No, it's not over the h. This over this over h here, this is by definition here. This one here, all right, probably.
No, I'm sorry. You see right at the bottom it says f1 plus h? Right at the bottom?
Here?
Yeah, it's like over the h, the square root.
No, it's not over. No, it's not. That's plus. That's square root of 1 plus.
I think I can explain this one. I think I can. Dan, the reason
Yeah.
why, the reason why the reason why it's 1, the square root is over 1 plus h is because 1 plus h is replacing x in the original equation.
Oh, we're saying why the h is under the square root.
Yeah, that's what I meant.
Okay. So that's because your x, you're supposed to have 1 plus h instead of x. So you see, your x is under the square root, right?
Uh-huh.
So now what I'm saying
Oh.
is, instead of this x, I'm gonna put 1 plus h.
Oh, because 1 plus h is now x.
There's no x, yes.
Okay.
Mhm.
Uh-huh. Yeah. Sorry, I thought you were talking about the definition of m. Yes.
So would that be -1 now?
Yes, that would be -1, absolutely. So now I can compute my m. So limit. So I have h going to 0. So I have square root of 1 plus h. The whole 1 plus h is under the square root minus 1 over h. So that's my limit, right? And now, of course, so when you compute the limit, we said the first step is always just to plug in number into the function here. So if h is 0, if my h is 0, so here, let's say h is 0, then you're gonna have like square root of 1 plus 0, and then minus 1 over 0. So that would be square root of 1, which is 1, minus 1 over 0. So that's 0 over 0. And that's indeterminate form. So this is indeterminate form. So which means that you need to find another way to compute this limit, right? So how do we compute such limit? So we said in the previous chapter on the limits, so we need to multiply by the conjugate. So it's like your m, which is so limit h going to 0, square root of 1 plus h minus 1 over h. So we said we need to multiply by the conjugate. So which means square root of 1 plus h plus 1, right, over the same thing, of course, because you don't want to change the expression you have, right? So you need to multiply and divide by the same thing. Now, why I'm doing this, because it's like, this would be like a minus b times a plus b. So that's like a squared minus b squared. You see, so this is like my a here, this is b, a minus b, and this is like a plus b, right? So this is like a squared minus, so that would be a squared minus b squared. So my m would be limit h going to 0, a squared, so that's the square root of 1 plus h squared, minus b squared, minus, so it's minus 1 squared over h, of course, here. This is this h here, and this thing here in the bottom, the same. So times square root of 1 plus h plus 1. So in the top, you have a squared minus b squared. In the bottom, you have this h times, the other denominator. So now I can get rid of the square root. So you see here, this square root here cancel out with this square. So now my limit h going to 0 is 1 plus h minus 1 squared. Of course, that will be minus 1 over the same stuff here, h is square root of 1 plus h plus 1. All right. And so the 1 minus 1 cancel out. So this here, 1, here 1 minus 1 cancel out, right? And so it's going to be like m equals to limit h going to 0. So you're going to have h in the top, h in the bottom times the square root of 1 plus h plus 1. And of course, the h, the top and the h in the bottom, they're going to cancel out too. So this is here, it cancel out. And of course, it cancel out. Then in the top, it's not 0. In the top is going to be 1 because this is like h times 1, right? So we are left with 1 in the top. And in the bottom, we're going to have the square root of 1 plus h plus 1. So it's going to be m limit h going to 0. So we are left with 1 in the top, not 0, and square root of 1 plus h plus 1. So you see, guys, so now we are done with the simplifications, right? And then, so all I have to do now, I just plug in 0. H equals to 0. It's supposed to be 0, right? So that will be 1 in the top, and then you're going to have square root of 1 plus 0, that's 1, and plus another 1. So that will be half. That's 1 over 2.
Okay, Professor, I see
So
how
that's,
you have.
that's how we, computed the limit for square roots in the previous chapter, right? When we had the square root, we said we had to multiply by the conjugate. So then you have like a squared minus b squared in the top.
Just remember to multiply by the conjugate.
Mm-hmm.
Okay.
Mm-hmm. And so that's my m. So my m would be half. And then, you see, so it's really important to know how to do the limits. So that's why I gave so many limits to compute in the homeworks, because even this is chapter, I mean, for the chapter 2 and even the next chapter, we're gonna still have to, compute limits. So it's really important that you know how to compute all these different limits, right? Anyway, so that's m is equal to half. Now in the step 2, I can find my.
So Professor, you see how you got 0 over 0 undetermined form? That's what I got. But then I didn't multiply by the conjugate, so that's why I got messed up.
Yeah, so that's not that the undetermined form. It's not supposed to be your final answer. You
Okay.
get undetermined form. It means you need to find another way to compute the limit. It's not
Hey,
supposed to be your final.
Professor, what if what if we get like a square root, but instead of it's cubed, or it's even to the 4th cubed root or whatever?
You mean like instead of a square root would be like instead of a square root we have like a third root, or
Yeah, 3rd root or 4th root, something like that.
well, then you still have to compute multiply by the conjugate, but instead of the square root, you will have to multiply by the third root, or 4/3, or whatever power you have.
Okay.
Okay, but the idea is the same actually. It's not. So now we can move to the next step. So the step 2, and now I can compute my equation. So again, the equation is supposed to be, so let me write the formula. So the equation is supposed to be y m x minus a plus f of a. So we know from step 1, we said m is 4. Sorry, m is half. Right, that's what we got from the step 1. M is half. A, we know what's a. I mean, a is 1. Right, that's that's a. So we said the equation of tangent line at x equal to 1. So a is 1, and f of x, f of 1. We said this is just square root of 1, which is 1. So now we can compute our equation. So it's y equals to half x minus a minus 1 plus f of a. So that would be plus 1. So that would be y equals to half x. So we distribute, right? So minus half plus 1. So that will be y equals to half of x plus half. So this is supposed to be your final answer. So this is the equation of the tangent line to f of x, which is the square root of x at x equal to 1. So this is tangent line to f of x, which is square root of x at x equals to 1.
Professor, I have another question.
Yeah, sure.
Would the limit m always be equal to well, the limit m age will be equal to 0 all the time, or no?
Yeah. Age goes to 0 all the time. Yes, that's by definition.
Okay.
That's by definition, right? And
Okay.
again, you think of age as the distance between the x and a, and you want your x to approach a as close as possible. So that's why you need. So this age again, it's just the distance between x and a, and you want your x to go to a, so you want your h to go to 0. So h, yes, is always going to 0. Always. That's by definition. All right, so let me just do number 2, probably not number 3 because it will be too much. But let me just do number 2. So number 2, we have f of x, which is, I think, sine of 2x. And we need to find the equation of the tangent line to this function at x equals to 0. Right? So, okay, so as usual, first step here, step 1. So we need to compute our slope m. So by definition, that's the limit, h going to 0 always. So this is always. Okay. it's not because at x equal to 0. It's just by definition, right? So it's always h going to 0. And then f of course, f of a plus h. So what's a here? So we said at x equal to 0. So my a is 0, right? So my a is 0. So that's a 0 plus h, right? So it's 0 plus h, which is h, right? So this is supposed to be 0 plus h minus f of a. My a is 0, so it's f of 0 over h, right? So m would be the limit h going to 0. F of 0 plus h, of course, 0 plus h would be just h. So that's f of h minus f of 0 over h, right? So, okay, so we need to find f of h, we need to find f of 0, right? So we need to find this f of h here and f of 0. All right, so first, f of x, we said f of x is sine of 2x. So if you want to compute now f of h, so instead of x, right, we're going to have h. So instead of this x, we're going to have h. So we're going to have sine of 2 times h. Right? So that's f of h. I need f of 0 too, right? Here, f of 0. So what will be f of 0? So let's compute f of 0. So f of 0, well, f of x is sine of 2x. So then f of 0 is sine of 2 times 0, right? So the angle is 2 times 0. So 2 times 0, of course, 0. So that would be sine of the angle 0. And we said sine of 0 is 0, right? So sine of the angle 0 is 0. Cosine of 0 is 1, but sine of 0 is 0. Sine of 0 is 0. Cosine of 0 would be 1. All right. So now, right. So now we can compute m. So then m, limit h going to 0. F of h is sine of 2h. Right. That's my f of h. Right. This one here. F of h is a sine of 2h minus f of 0. Minus f of 0, it's 0, right? Here's my f of 0. That's my f of 0. So sine of 2h minus 0 over h. So, I mean, m would be just limit h going to 0 of sine of 2h over h. Right? So now we want to compute this limit. Of course, if you start with the first step, but by, you just replace h by 0. So then you're going to have like sine of 2 times 0. So that's sine of 0. And we said sine of 0, sine of the angle 0 is 0. So we're going to have 0 on the top and 0 on the bottom, right? If you just replace h by 0. And 0 over 0 would be undetermined form, right? So then we need another way to compute this limit because you're going to have 0 over 0. So then that, guys, because we have, remember, if you have sine, remember the trick. If you have sine of, a of x, so remember if you have limit x going to 0 and you have the same number of x's in the top, and the sine of a of x over a of x, we said this limit here would be 1, right? So here it's sine of 2h over h. So we need the same number of h's. So in the top I have 2h, so I need 2h in the bottom to make it 1. But if you multiply the bottom by 2, you need also to multiply the top by 2. So here's another 2 here in the top. So now I can say this sine of 2h over 2h, that will be 1, right? So there's going to be 2 in the top times 1. So my m would be 2 times 1, which is equal to 2. Right, so you see, guys, we have to use this formula with the sine of a of x, sine of a over x over a over
Wait,
x.
Professor,
Yes.
I didn't catch it. How did you get the 1 again? Did you divide out 2h by 2h?
No, never do that. I mean, the 2h in the top, that's the angle. That's sine of the angle. So you cannot separate the sine from the 2h. It's a sine of the 2h. You cannot, it's not sine times 2h. It's sine of the angle 2. Okay, so you cannot separate the sine from
Or
the,
did you do
but so yeah, what I'm
did you
saying,
do the substitution? Okay.
no, I
Did
didn't
you do the substitution thing?
no, I didn't do a substitution. This is a trick we learned in the chapter 1 when we compute the limit. So so what I was saying is, so what I did here, I used this formula. Let me write formula for you. So here, so I used this limit x going to 0, sine of a of x over a of x, it's equal to 1. All right.
Oh, okay.
Again, you cannot cancel out the ax here. This is sine the angle. That's angle ax. So it's like saying sine of 3x over 3x. For example, sine of sine of or sine of 2x. 2x, that will be 1, right?
Okay.
So what I'm saying here, I have sine of 2h over h, right? So you see, all you need is so here you see sine of, this is a sine of 2x over 2x is equal to 1. Here it's sine of 2h over, but it's not 2h, it's just h, right? So we're gonna make it 2h in the bottom. Then you get 1.
Also,
yes.
I just want to make sure, is sine and like their function, it's a function, correct?
It's not just sine by itself. It's sine of the angle.
Oh, okay.
It's not sine by itself. That's the thing. You cannot separate the sine from the 2h. So it's a sine of the angle x or sine of the angle 2h.
Okay, because I was wondering why you just kept on replacing why you replaced 2x with 2h instead of just replacing everything in it, but that makes sense.
Yeah, I mean, yeah, you cannot just cancel out the h or, So here I make it 2h in the bottom, so I can have the same number of h's in the sine and in the bottom, so that will be 1. But because I multiplied by 2 in the bottom, I need to multiply the top by 2 too, right? So that's why I got 2 times 1. Because again, I'm using this formula here, this one here. Okay, so yeah, so my slope m is 2, so I am almost done. So now I can move to the next step. So you see, guys, again, it's really important to know how to compute the limits. So if you have a trouble with the limits, I mean, especially with the homework 1 and 2, right? So we need to make sure that you know how to do the limits and the homeworks, because again, we're gonna use them in this chapter 2, okay? And the whole chapter 2. Again, because the derivative is also about their limits. So we're gonna need to compute a lot of limits in this chapter. All right, so now in this step number 2, you have the equation of your tangent line. So that will be, again, y mx minus a plus f of a. F of x is sine of 2x. And a is equal to 0. All right, so that'll be y m. M is 2, right? That's from the step 1. M is 2. X minus a is 0, plus f of a. So that's the sine of 2 times 0, right? And sine of 2 times 0 is sine of 0, which is 0. So f of 0 is just 0, right? So here f of 0 is going to be also 0. So then the final answer, of course, would be just y equals to 2x. So this is the equation of the tangent line to the function sine of 2x at x equal to 0. So this is tangent line to f of x equal to sine of 2x at x equal to 0. So is there any more questions? Any question, guys? Okay. Yeah, so I won't do number 3 because it's gonna be probably we're gonna go for another 10 or 15 minutes because there's a lot of computations in number 3. So I'm gonna just skip the number 3. And yeah, so I was saying this number m, which is limit h going to 0, etc. It's actually, that's the definition of the derivative. So let me probably move to the next page. So if m exists, so this is the definition actually of the derivative, a definition. So if the number m exists, so if m, which is by definition limit h going to 0 of f of a plus h minus f of a over h, if this number here exists, I mean, if the limit exists, you remember, guys, sometimes the limit do not exist. I mean, sometimes, the limit from the left is different from the limit from the right. So, and this limit is from both sides, right? So sometimes the limit do not exist, and we will see examples where m, the slope m here, do not exist. But if this number m exists, then it's called actually the derivative. Then it's called the derivative. All right, so derivative of f of x at the number a, right? And if this number exists, we say that the function f is differentiable. So if m exists, so we say that f of x is differentiable at x equal to a, is differentiable. So it's like saying like f of x is continuous. Now we have f of x differentiable. So f of x is differentiable, at a. Right? And of course, we see examples, where the function is not differentiable, right? Yeah, for the notation, guys. So actually, we denote the derivative. We denote the derivative m by, so m is f prime. This is prime here, f prime of a. So that's actually, so that's the definition of this m is exactly the derivative of the function f at a, right? And so here's the notation, guys. Again, you have this f and you have this, like this line here. So that will be f prime. So we say this is f prime of a, right? This is, so we say this is f prime of a, f prime of A. Okay. All right. So, okay. So let's compute a couple of derivatives. And again, it's just about the derivative is just this slope m, right? So examples. Let me give you a couple of examples. 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 Well, we can probably take probably you can take a break of 5 minutes before the examples because I have a lot of examples anyway. Yeah, so we can probably take a break of 5 minutes, and then I will continue with the examples. I will give you an examples where the function is differentiable and where the function is not differentiable, and then we're gonna also compare this notion of derivative or differentiability with the notion of continuity, right? We are supposed to know when the function is continuous or not. Okay, so then we're gonna compare it to the case where the function is differentiable or not. Okay, so we're gonna try to make like a connection between the continuity and the differentiability. All right. But anyway, so let's take a break 5 minutes, and then I will continue with the examples. All right. So 5 minutes. So let's say we'll come back at 7:50. All right. That works for
Professor,
you guys?
Professor, can you scroll a little bit down?
Up.
Yeah,
Mm-hmm.
thank you.
Mm-hmm. Sure. I think in the homework number 2, let me see. So what did you have in the homework number 2? Let's see, documents, homework number 2. Okay. No, sorry, not the homework number 2. The homework number 3, right? The homework number 3 is due tomorrow, right? So the homework number 3, so we have again a problem about the first problem is about continuity, right? Second problem is about the intermediate value theorem. I think we did a couple of examples similar to the problem, similar to the problem number 2. So again, problem number 2 is about the intermediate value theorem. And then you have, okay. So actually you have 3 problems about the tangent line to the functions. Oh, I gave x squared minus 1. Yeah, actually I did the problem number 3. I didn't know that actually. Yeah, so, and then you have 1 over x, and then you have sine over x. Okay, so, I mean, problem number 3, I just did it in the beginning of the lecture. I did actually, I didn't know about this. I mean, I wasn't sure what's the problems in the homework. but I did the problem number 3 in the beginning of the lecture. I did a very similar problem to the problem 5. Problem 5 is the tangent line to the function sine of x, and I did the sine of 2x, all right? So it's almost the same thing. But then, so actually all you have to do is just the problem number 4. All right. Anyway, and of course, guys, I mean, if you have a question about the homework number 3, let me just, please let me know, all right? So it's, again, it's due tomorrow.
I have a question.
Mhm.
The one you did with the sine of 2x, I did a different way, but
What do you mean different way? How to compute the limit?
no, I did the same method you said to use, but instead of f of h equal to h, I did f of 0 plus h, then I distribute everything.
I mean, that's what I did. I did f of 0 plus h. That's f of h, and I said that would be sine of 2h.
Yes, I'm saying instead of saying sine of 2h, I did sine of 0 plus 2h, so I distribute like a sine of 0
Oh,
times the cos of 2.
okay. I see what you're saying. Yeah, okay. Yeah, that's another way to do it. Yeah, that's very good. You're saying you use the trig.
Yeah,
Okay, yeah, that's another way to do it. Yes, absolutely. Yeah, very good.
my question is like f of 0 plus h equal to f of h.
Yes,
Okay,
yeah, sure, of course. So 0 plus h is h. Yeah.
okay, thank you.
Sure. Yeah, you're right. Absolutely. You can also use the trig identity. Yeah. All right, guys. I guess a break of 5 minutes is over. Okay, so let me continue with the examples here. So we'll see in the examples, there are some examples where the function is differentiable and other examples where a function is not differentiable. And I will explain what's the idea behind, so when you should expect the function is differentiable or not, okay? It's like, remember like when we discussed the continuity, right? We said, I mean, if you don't have like a hole or a jump or a break in the graph of the function f, then f would be, continuous, right? So, but of course, if there is a hole or jump, then f is not continuous. But anyway, so we're gonna discuss a little bit when the function is differentiable or not. So okay, so for examples, let me start with a very simple example. Example number 1. So first example, I'm going to take very simple function. So example number 1. So I'm going to take just, f of x equals to 2x plus 1. All right. And so the question is to find, or the question is f differentiable at x equal to 1, right? And if f is differentiable, then you need to find f f prime of 1, right? So, so when you ask such a question, is f differentiable at x equal to 1? So what does it mean for f to be differentiable at x equal to 1? Again, we said by definition, if this number m here exists, okay, then the function f would be differentiable. All right, so we see here this the definition here. So we said it's differentiable if m exists, right? If the number m exists, right? So all you have to do again is to compute this number m, and if m exists, then the function would be differentiable at a. So all we have to do is so the step, first step, it's only actually one step. So step 1. Well, all we have to do is to compute m. Compute m, which is supposed to be, again, m, supposed to be this f prime of 1. Right? So again, a here, guys, is 1, right? A is 1, right? Because it says f differentiable at x equal to 1. So my a is 1. My f of x is 2x plus 1. All right, so I can compute m. And if m exists, then f would be differentiable at 1, right? So let's compute m. So m, again, by definition, is supposed to be limit h always going to 0, no matter what. Okay, so it's always going to 0. F of course, a plus h. So a is 1, so it's 1 plus h minus f of a. A is 1, so minus f of 1 over h, right? So first, I need to find f of, so in this definition, I need to find f of 1 plus h, and then I need to find f of 1, right? So let's find f of 1 plus h. So f of x is 2x plus 1, right? So what will be f of 1 plus h then? So you just replace, you have this x here, you replace your x by 1 plus h. So we see this x here, you're supposed to replace the x by 1 plus h. So that will be 2 times 1 plus h plus 1. Okay. So, and again, guys, you should think of this circle like a parenthesis. So this is actually, you know, so this is f1 plus h is supposed to be 2 times parentheses 1 plus h, right? And then you have plus 1. So then f of 1 plus h would be, so 2 times 1 is 2, 2 times h is 2h, and then you have plus 1. So this f of 1 plus h, it's, so you see here, this is 2 here, plus 1, so that will be 3. So that's equal to 3 plus, and then you have this 2h here. So that's 3 plus 2h. Now, we need to compute f of 1, right? We compute f of 1 plus h. Now we need to compute f of 1. So f of x, again, is just 2x plus 1. Is 2x plus 1. So then f of 1, that will be 2 times 1 plus 1. So that will be equal to 3, right? So now I can compute my limit. So my m is limit h going to 0. So f of 1 plus h, that's supposed to be 3 plus 2h, right? So we have 3 plus 2h. And then we have this minus. So here's my minus. And then we have f of 1, right? F of 1, we said it's 3. So minus 3, right, over h. All right, so then the 3 cancel out. So it's just 2h over h. So my m, my m is limit h going to 0 of 2h over h. So h cancel out, right? So that'll be equal to 2. Okay. So my m exists, right? And it's equal, and actually it's equal to 2. So my m.
I have a question.
Yeah, please. Yeah.
How can you know M doesn't exist?
We'll see examples where m do not exist. I mean, it's m is a limit, right?
Mhm.
And sometimes the limit from both sides do not exist.
But here we just looking for H when H goes to 0.
Yeah,
We're
but when
looking for left or right.
yeah, I mean, h going to 0, of course, it means yeah, in some cases, I mean, the next example you see, so you have to distinguish between the case h going to 0 plus and h going to 0 minus. So probably you can have like two different limits. So then the m do not exist. Or for example, if you find if m is equal to infinity, right? So and if m is infinity, then it's actually it's undefined, right? So it's do not exist. It's infinity, right? So when I say m exists, it means m is equal to some finite number. Right? But anyway, we'll see in the next example, m do not exist in the next example, all right? So, but here in this example, m, so my m is equal to 2, so m exists, okay? So if m exists, then f of x is differentiable at a. My a is 1, right? So it's differentiable at 1. At 1. And f prime of 1, it's by definition, it's supposed to be equal to m, right? That's the definition, right? Derivative of m at 1 is equal to m, and this number m turns out to be equal to 2, right? So if your m is a finite number, then it exists and your f would be differentiable. And so here, derivative of this.
Wait, Professor, I can't see the rest. Fx is differentiable at what?
At 1.
Oh, 1, okay.
Mhm. At 1, right? Because that's our a. That's the at 1. Mm-hmm. Is there any question, other question, guys? So that's how we compute the derivative at a. Well, all you have to do is go to compute this number m, which is by definition the derivative of the function f at a. But so in this case here, guys, f is differentiable, right, at 1. Now, if we so what about the continuity here? Is f of x continuous at 1? So my function f is just 2x plus 1, right? So my function f is it's 2x plus 1, right? And I mean, of course, if you just graph 2x plus 1, it would be just a line like this here, let's say, like here, all right? So the question is f of x continuous at 1? Well, I mean, if you just check the graph, if you don't want to do the definition, right, and you want to just check the graph, you can see here, here 1, this is 1 here, right? This is f of x. And you see here at 1, the image at 1 here, I mean, the line is just, we have like a straight line, right? So it's just continuous. It doesn't, there's no hole or jump or break at x equal to 1, right? So it's just a continuous straight line, right? So then then f would be, of course, would be continuous at 1, right? Remember, we also said that, 2x plus 1, I mean, here we have just the power of x, right? So f of x in this case would be a polynomial, right? And because we have just powers of x. And we said if we have polynomials, then polynomials are actually continuous everywhere, right? So what I'm saying is just that this function f is continuous everywhere, actually, right? So, so just to, so this is a remark, because at some point later we're gonna make a connection between continuity and differentiability, right? So you need to understand, guys, the difference between continuity and differentiability, right? So what I'm saying here is that this function f of x, which is 2x plus 1, is a polynomial because, polynomial by definition, it's when you have just powers of x, right? So here we have just power of x power 1, right? This is x power 1. So it's a polynomial. So it's continuous everywhere. Continuous everywhere. Right? In particular, of course, at a equal to 1. In particular, at 1. All right. So, I mean, this is just an example. I mean, this is a very simple example where the function is continuous and differentiable, at the same point. So it's differentiable at 1. It's differentiable at 1, and it's also continuous at 1, right? Because, well, later we're gonna see examples where, for example, f is continuous, but f is not differentiable at that point, okay? But anyway, so this is an example where the function is at the same time continuous and differentiable. All right. Is there any question about the remark here about the continuity? So keep in mind, guys, I mean, we have a definition for continuity. We have a different definition for differentiability, right? So it's two different definitions. But anyway, later we're gonna make like some connection between the two definitions. All right, so now let's have our first example where f is not differentiable, where this number m do not exist. So that's I'm gonna move to the next page, if it's all right with you. So I'm gonna move to the next page. So that will be example number 2. And in this example number 2, I'm gonna take a very simple function. So I'm gonna take f of x equal to absolute value of x, right? And the question is f of x differentiable at x equal to 0, okay? And if it's differentiable, so we need to find f prime of 0. So, absolute value of x. Remember, guys, I mean, absolute value of a number is always a positive number, unless x is 0, so then that will be 0. But otherwise, a positive absolute value of x is always a positive number, right? So what I'm saying is this function f of x equal to absolute value of x. Another way to write this function is, so f of x is equal, so if, if you have f of -5, right? F of -5 would be absolute value of -5. So what would be the absolute value of -5? It's +5, right? So you take the opposite, right? So if x is negative, if your number is negative, then you need to take the opposite, right? So if this x here is negative, then f of x is going to be the opposite if x is negative. So it's going to be minus x, the opposite of x, if x is negative. So x is negative means that x is less than 0. And if your x is positive, so for example, f of 3, that's absolute value of phi, right? Absolute value of phi, of course, is positive phi. It's the same number. So if x is positive, then it would be the same number, right? The absolute value would be just the same number. So if f of x would be equal to x if x is positive, if x is larger than 0, right? So that's another way to write or to express the absolute value of x. Does it make sense to you guys? All right.
Yes, Professor.
Okay, perfect. So then, well, so the question is f of x differentiable at 0? So you see the problem here. So my function f is expressed by two different equations here, right? I have the equation minus x. This is my first equation, right? If x is, that's the condition here, if x is negative. And I have another equation, right? Which is x, if x is positive. So like this absolute value of x is actually described by two different equations, right? Anyway, so I want to check if f of x is differentiable at x equal to 0, right? So all you have to do, and the main step, so what we have to do is to compute m. Was supposed to be limit h going to 0 of, again, f of a plus h minus f of a over h, right? Over h. Okay, so what's my a here? The question is f of x differentiable at x equal to 0, right? So my a would be 0, right? So here's my a. So x is equal to 0, so which means that my a is 0, right? So you see here f prime of 0, so my a is 0. So my a is 0. My f of x is absolute value of x, right? That's my function f. Now, so first I need f of a plus h. So let me write it down for you here instead of a. So we have 0. So that's the limit h going to 0, f of 0 plus h minus f of a. Minus f of, we said a is 0, right? So it's f of 0 here. This is f of 0 over h, right? So, of course, 0 plus h, I mean this, so this 0 plus h would be h. So my m is just limit h going to 0 of f of h minus f of 0. So what's f of 0? F of x is the absolute value of x, right? So f of 0 would be just absolute value of 0, which is just 0, right? So it's just minus 0 here over h. Now, what's f of h? Well, I mean, f of x is absolute value of x. So then absolute value, then f of h, it's just absolute value of h, right? This is limit h going to 0. So this is absolute value of h over h, right? That's f of h, right? It's absolute value of h. All right, so now we need to compute this limit here. We need to compute limit limit h going to 0 of absolute value of h over h, right? So of course, if you just replace h by 0, so here if you say my h is 0, then you're going to have, of course, absolute value of 0 over 0, which is 0 over 0, which is indeterminate form. Right, so this is indeterminate form, so we need to find another way, to compute this limit. Okay, so how do we compute this limit? Well, so again, this is, remember guys, this is like having an absolute value in the limit, right? We had a couple of problems where you had to compute the limit with the absolute value, right? So this absolute value of h here, the top here, I mean, it's not. It's not just h, right? It depends, right? It depends if h is positive or h is negative. So absolute value of h. I mean, if h is positive, then yes, absolute value of h would be h. But if h is negative, then absolute value of h would be the opposite, right? That would be minus h. So here it depends. So this absolute value of h depends on the sign of h, right? It depends whether h is positive or negative, right? So now the question is h positive or h negative? H is going to 0.
Wouldn't the opposite be negative h?
No, actually, no, not really. You say h is going to 0, so you are here in the number line, right? Here's 0, right? So, I mean, there are two different ways to approach 0. So h could approach 0 from the left,
Or the right?
from the right. And it makes a huge difference because if h approach 0 from the right, then h would be positive. So here, this would be positive because it's on the right side of 0. But
Yes.
if h is approaches 0 from the left, then it would be
Be
negative.
negative, right?
Right. So it's, you see now I have like two different cases. So this limit here, this m, actually we have to distinguish between two cases, right? When h approach from the left and h approach from the right, because because of the absolute value. So I have to distinguish between. So there are two cases. So first case, so m, that's the limit, h going to, let's say, 0 minus. So 0 minus means h approaches 0 from the left, right? So this is from the left. Okay. So of the absolute value of h over h. And so that will be limit h going to 0 minus, and then h approaches 0 from the left. So h is negative, right? In that case, right? So h would be negative. And if h is negative, absolute value of h, so this absolute value here would be minus h. So here, because h is negative, because it approaches 0 from the left. So it's on the left side of 0. So it's negative, right? Over h. All right. So we're going to have minus h over h. And so then the h cancel, then the h cancel out. So this h here. So it's going to be just -1 in the top and 1 in the bottom. So then m, m is equal to -1 over +1. So m is -1. Okay. So that's the first case, when h approaches 0 from the left. The second case is when h approaches 0 from the right. And if h approaches 0 from the right, it means that h is positive because it's on the right side of 0, right? So this is here from the right. So it's then h would be positive. And if h is positive, so this, so here we have this absolute value of h over h. So this will be equal limit h going to 0 plus. Then this absolute value of h, because h is positive, so because this h is positive, so this would be plus h. So here h is positive. It's on the right side of 0, so it's positive. So its absolute value would be the same number. So it's h, absolute value of h is h over h, and of course then h cancel out, so then m would be plus 1 over 1, which is positive 1. So here you see m, our limit m. So we have two cases. If you approach 0 from the left, you get -1. M would be -1. And if we approach 0 from the right, you get +1. So then the conclusion is that your m do not exist, because m is supposed to be the limit from both sides. But from the left, you get -1. On the right, you get +1. So they are different, right? They are not equal. They are not equal. So your m. So conclusion here. Conclusion is that your m, which is your m, which is supposed to be the limit h going to 0 of absolute value of h over h. This is from both sides, right? This is supposed to be the both sides. This is supposed to be from both sides. Both sides. So then this limit here do not exist. So m do not exist. Because the limit from the left is different from the limit from the right. Because limit h going to 0 minus is different from the limit h going to 0 plus. Right? So your m do not exist. So if your m's do not exist, then m, then f of x. So then f of x is not differentiable. Is not differentiable at x equal to 0. At x equal to 0. Okay. So f prime of 0 do not exist. All right. So this is an example where like the function is not differentiable, right? And you see, like in this case, our limit do not exist, so it's not differentiable. And again, guys, I mean, you can see, I mean, if you wanna visualize this conclusion here that f is not differentiable, it's actually it's actually clear from the graph. So the idea is the following. So why it's not differentiable? Well, let's take a look to the graph of f of x. Okay, my f of x is supposed to be absolute value of x, right? So it's like, you have like a straight line here and then another straight line here. Okay, so so this is supposed to be absolute value of x. All right, and here's my a. A is 0. All right. So you see, guys, here at a equal to 0, the slope. I mean, if you have, imagine you have a tangent line. So from the left side here, the slope would be, the slope of this line. So this line is going down, right? So which means that the slope is actually negative, right? And if the slope is negative, it's actually a -1. So the slope of this, so the slope here is -1 on the left of 0. Now on the right of 0, on the right of 0, if you take the tangent line here, on the right of 0, then the slope of this line here, this line here is going up, right? It's increasing, so the slope is positive. So the slope of this line here would be positive 1, right? And that's exactly what I'm saying. So you see, the derivative from the left is supposed to be negative 1, but from the right, the derivative, the slope is positive 1, right? So at 0, you have like two different slopes. From the left, it's negative 1, and from the right, it's positive 1. So that's why actually this function f is not differentiable at 0. So you have this, you have this corner, at 0. So, you have two different slopes. From the left, you have a negative slope, and from the right, you have a positive slope. And that's why actually f is not differentiable, because you have two different slopes, one coming, a negative one coming from the left and a positive one on the right? So that's actually the geometric interpretation of the fact that this function is not differentiable at 0. So the idea is, whenever you have like a corner, a corner in a graph, then it's not differentiable. So this is like a general remark. So this is like a general remark. So if you have a corner, so what I mean by corner is like, you have like a vertex, something like, it's supposed to be like a, so it's like you have like a triangle or something, right? And here, this vertex would be your corner, right? So you have a, so this is your corner here. So if you have a corner in the graph, then it's not differentiable in a graph. Then f is not differentiable at that point. Differentiable at that point. And again, the idea is because the slope from the left is going to be different from the slope from the right at that point. Does this make sense to you guys? Is there any question? You see why it's not differentiable? It's like, it's like having two different slopes, one from the left and one from the right.
Yes, Professor.
Okay, perfect. Anyway, so this is an example where f of x is not differentiable. But now I'm gonna just make a comment about the continuity, right? So f is not differentiable. Okay, so here's a question for you guys. Do you think that f is continuous at the 0 in this case? Again, the graph is just, so your graph is, here's your graph. So, right, this is the graph of absolute value of x, right? And here is 0. Okay, so my question is f of x continuous at 0?
No,
Why?
because f of
What's f of 0?
let me see. It's 0.
Okay, so now when you approach 0 from the left, what will be the limit of f of x? F of x is the absolute value of x, right? So what I'm saying is f of x is supposed to be, minus x if x is negative, and positive x if x is positive, right? So if you approach x from the left, if you approach 0 from the left,
Minus 1.
Sorry?
-1.
I mean, the x going to 0. So you replace x by 0.
Oh.
It's going to be minus 0,
All right, -0.
which is 0, right? And if you approach 0 from the right, so what would be the limit of f of x? So what I'm saying, guys, is, so if you compute, so if you compute, in the continuity, you're supposed to compute f of 0. So f of 0 is the absolute value of 0, it's just 0. Now you're supposed to compute the limit of f of x going to a. So my a is 0, so x going to 0, right? And so here I have two different cases, right? Because f of x is given by two different equations, right? Minus x and x, right? So if you approach 0 from the left, so which means that your x is negative, then you need to use minus x. But anyway, if you replace here x by 0, it's going to be minus 0, which is 0. And if you approach x from the right, 0 from the right, so we're going to use a positive x, right? If you approach 0 from the right. So then that would be plus 0, and which is again 0. So then, so this limit here exists.
Yeah.
Right? It's from the left and from the right are equal. So then limit of f of x going to 0 is actually equal to 0. Because, the limit from the left, this one here is the same as the limit from the right. So then the limit from both sides is equal to the 0. So it exists, and actually, and the conclusion is it's actually equal to f of 0. So here, so this limit here of f of x going to 0, is the same as f of 0, which is 0. So yes, f of x is continuous at 0. F of x is continuous at 0. Right? And again, guys, remember what I said. Continuous means it's a continuous, there's no jump, or there's no hole, or there's no break in the graph at 0. And of course here, there's no break or hole in at 0, right? It's just a continuous, the curve, it's just a continuous line. It doesn't, you don't stop at 0. There's no hole or jump at 0, right? So it's a continuous line. So yes, f of x is continuous at 0. So you see, this is a really good example where the function is continuous, but it's not differentiable at 0. So, so this is an important remark. So f of x equal to absolute value of x is continuous, but not differentiable at x equal to 0. Okay. So yeah, so this is my example number 2. As I said, so this is an example where the function f is not differentiable. But anyway, all you have to do, guys, is, if you want to check if the function is differentiable, all you have to do is to compute this m, right? This number m. But you see, in this case, is in this absolute value of x, when you compute m, we end up with two different cases, right? Here, remember, we end up with two different cases. There is an m when h goes to 0 minus, and there's another m when h goes to 0 plus, right? That's why we got two different values depending whether we approach 0 from the left and the right. But anyway, so, and of course, in this case, your m do not exist because the limit from the left is different from the limit from the right. So f is not differentiable. But anyway, so in general, all you have to do when you want to check the differentiability is to compute this number m and to check if it exists. So as you can see in this example, it do not exist, right? All right, so we can have one more example, and then I can probably give you an exercise. Yeah, let's do another example. Okay, and an example where, so you see this absolute value of x. The problem with this absolute value of x is that it's actually described by two different equations, right? You have minus x if x is less than 0, and positive x is if x is larger than 0. So that's why we said there is a potential problem in at x equal to 0, because that's where that's where your x, so your x is less than 0, x larger than 0. So then you have a potential problem with the differentiability at x equal to 0. So now let's have another example with function f described by two equations, but the function would be differentiable, right? Instead of like here where it's not differentiable. So let's have one more example, and then probably next time I will give you an exercise where you have to, check if the function is differentiable or not. All right. So one more example, guys. One more example. So that will be example number 3. Example number 3. So here's my yes.
Can I see the conclusion?
Yeah, sure. Yeah, here in the bottom. Sure. Probably here in the bottom.
Yeah.
Yeah, the conclusion is that actually function is continuous, but yeah, it's continuous at x equal to 0. Again, guys, you think of the continuity as, I mean, the function is continuous, is like saying the function is, there's no interruption in the graph of the function f, right? So it's like you don't stop, or there's no interruption in the graph of the function, right? So like here, we had this absolute value of x, and the graph was like, so here's my graph. So I didn't stop at x equal to 0, right? So it's a continuous curve. I mean, I didn't stop, or there's no interruption here at x equal to 0, right? So it's continuous. There's no hole there, right? Or break.
Thank you.
Sure. Okay, so let's have one more example, guys, with a function defined by two different equations, but the function is going to be actually differentiable. So let's say f of x is equal to, let's say x squared minus 2 if x less than 1. All right, and 2x. So here, -1, 2x minus 3 if x is larger or equal to 1, right? So the question is the following. First, is f of x differentiable at x equal to 1? Okay, and if it's differentiable, you need to find f prime of 1. Right. Second question is f of x continuous at x equal to 1? Again, it's just to compare continuity to the differentiability, right? So let's start with the differentiable. If f is differentiable, right? Number 1. Again, if you want to find out whether the function f is differentiable at x equal to 1, all you have to do is to compute the number m when a is 1, right? And of course, if the number m exists, then f would be differentiable. So let's compute the number m. Okay, so all you have to do, you have to compute our slope m. So m, which is limit h going to 0 of f of a plus h minus f of a over h. And again, h always goes to 0, right? So, so what's my a here? It's x equal, so the question is about x equal to 1, right? So my a is 1, right? And here's my f of x. So f of x is described by two different equations, right? All right, so then another thing, first, there's this, also there's this f of a, right? So what will be f of a in our case? So what's f of 1? So which equation are we gonna use for f of 1?
Second.
The second one, right? Because x can be equal to 1, right? X is larger or equal to 1. So x can be equal to 1. So we need to use the second equation, right? So second equation here. So that's 2 times 1 minus 3. So that's negative 1. So f of 1 is negative 1, right? Okay, so now I can compute my m. So m is limit h going to 0 of f of a plus h. A is 1, so it's 1 plus h minus f of a, f of a, f of 1, and f of 1, this is f of a, and f of 1 is negative 1, so it's minus, so here's my minus, f of a, so it's minus negative 1 over h, right? Okay, so now the question is, I need to compute, so let me write again for you the function f. So, so we need to compute f of 1 plus h, right? So let me remind you, f of x is supposed to be, 2x squared minus 2 if x less than 1, and then x, sorry, what was f of x? So x squared minus 2. So this is x squared minus 2. X squared minus 2. And the second equation is 2x minus 3. Yes, so here's my second equation. So it's 2x minus 3 if x is larger or equal to 1. All right. So in this m, I need to compute f of 1 plus h, right? This f1 plus h. So what's f of 1 plus h? Which equation I'm going to use? So here, the question is, what's f of 1 plus h? So which equation we're going to use, guys, in this in the limit here?
X squared minus 2.
The
But-
first one.
Square minus 2?
Yeah.
Why is that?
Because x
Because
is
it's less than 1.
less than 1.
What's x? X is supposed to be the 1 plus h, right? The x, that's my, here's my x, right? It's
Oh,
supposed
1 plus 0. Okay.
1 plus h. So
1 plus.
1 plus h, is it larger or less than 1?
Larger.
Nope.
It would be equal to 1.
Nope.
What?
1 plus h is actually depends.
So it's 1h?
No, so no, because, okay, so because again, your h goes to 0, right? So
So it's gonna be 1 plus 0.
nope, no. When you say h goes to 0, it's never equal to 0. it means it's very close to 0, but it's never equal to 0. So actually, so here's 0, right? So if you approach 0 from h approaches 0 from the left, so then h is negative, right?
Yes.
So if h is negative, 1 plus h, is it larger or less than 1? If h is negative,
It's less
it's less. So here,
because it's negative h.
yes, so it's negative. So it's 1 plus h here would be less than 1.
And if it's on the positive side, then it would be more than 1 or equal to.
More than 1, absolutely. Yeah, that's the idea. So here on this side, if your h approaches 0 from the right side, then 1 plus h, because h would be positive, right? If you're on the right side of 0. So then 1 plus 8 would be larger than 1.
How do we know if we're on the right or left side, though?
Oh,
What do you mean, how do we know?
Yeah, for the 1 plus h.
Yeah, because, okay, so the thing is, you arrive at, you need to evaluate this f of 1 plus h, right? So you need to figure out which equation you need to use, right? So the question is, which equation I'm going to use, the first or the second, right? So to answer the question, I need to figure out whether 1 plus h, right? The conditions here to use the equations is if it's less than 1 or it's
Or
larger than 1,
equal to.
right?
Mhm.
Okay, so we need to figure out whether 1 plus h is larger than 1 or less than 1. So that's the question. Is 1 plus h larger or less than 1? Well,
And in this case, we don't know.
in this case, we don't know. It depends. Yeah, absolutely. It depends because your h, you see this h here, h approaches 0, which means that h is very close to 0. It's not equal to 0. It's very close to 0. It approaches 0. And if you approach 0, you can approach 0 from the left or from the right. And the thing is, if you approach 0 from the left, it means that your h is negative, then 1 plus h would be less than 1. And if it's less than 1, so then you have to use the first equation.
Wait, since h is approaching 0 and you have a piecewise function, that means that you would approach it from the left.
No. So what I'm saying is, you see here limit h going to 0. It means that you're gonna approach 0 from the left and from the right, from both sides.
so we're gonna compute two limits.
Yes, of course. We're gonna compute two different limits.
Okay.
So when you say h approaches 0, here it means h, this is both sides limits. This is both sides, right? But the problem, again, in this definition is, what's this f of 1 plus h, right? This f of 1 plus h, you need to figure out what's f of 1 plus h. And so we need to determine which equation you're gonna use, right? So you need to know whether your 1 plus h here, if it's less than 1 or it's larger than 1. And what I'm saying is, because we have both sides, so if you pick the left side, then h would be negative, then 1 plus h would be less than 1, then you have to use the first equation. And the other side, if your h approaches 0 from the right side, then h would be positive, then 1 plus h would be larger than 1, so then you have to use the second equation.
I have a question.
Mhm.
So if we use, you say we're gonna compute two limits,
Yes,
0 minus and 0 positive.
yes,
So we're gonna have two value of m.
yes.
And if m,
Equal. They can be equal, they can be different.
yeah, if they are different, then which value we give to m?
Yeah, so if they are different, then f is not differentiable. The m do not exist. And if they are, if they are not equal, then f is not differentiable, m do not exist. But if they are equal, then yes, then m exists and f would be differentiable at 1.
So if you have a piecewise function, it doesn't matter which function you use, and as long as you use the other one also?
No. You have to be careful. You need to check for which values you are. So here we are interested in 1, right? if, for example, I'm interested in 2, let's say I want to check if the function is differentiable at x equal to 2, right? Then at x equal to 2, I don't have such a problem, because at x equal to 2, 2 is larger than 1, then it's clear which equation I'm going to use. I'm going to use the second one, right? But here, the thing is, this is x equal to 1. And at x equal to 1, I have like 2 different equations, one from the left and one from the right.
Mhm,
You know what I'm saying?
mhm.
It's like, it's like, so what I'm saying is like, you have your graph. Okay, here's your graph, all right? Here's 1, here's 2. And I have 2 equations. I have a first equation here coming from the left, and I have a second equation coming from the right, okay? So the thing is, I don't know what's going on here at 1, right? So because I have 2 different equations. But at 2, for example, if you take a different value, let's say here, so here at 2, oops. So here at 2, so let's take, here's at 2 here, right? This is here the image of 2, right? And you can see from, if you zoom in, from the left and from the right, we have the same equation, right? So at 2, you don't have such a problem. But at 1, because at 1 you have, 2 different equations, the one from the left, which is the green one, and the one from the right, which is the red one, right? And that's why here, when you have, if your a is 1, then you have to check the limit from the left and the limit from the right. But at 2, you don't have such a problem. At 2, there is only one limit. So here it's just one limit to compute, because it's one limit because you have the same equation coming from the left and coming from the right. But here at 1, you have 2 different limits, 2 different limits. So you see what I'm saying?
Okay, but okay.
Here,
So let me
sorry.
try to get this straight. So since there's a 1 and 1 plus h, you're going to use the the first one, x squared minus 2, right?
Nope, I'm gonna use both,
Oh,
because 1 plus h, um, depends on h, whether it's less or larger than 1. If h is negative, then 1 plus h would be less than 1, then I would use the first equation, right? And if h is positive, then 1 plus h would be larger than 1, right? So then
mhm.
I have to use the second equation.
But we don't know what h is.
Yes, we don't know what h is, but what we can do is we can distinguish between 2 cases. The case when h is positive and the case h is negative. So if h is positive, then 1 plus h would be larger than 1. Then I can use the second equation, because that's where the x is larger than 1. And if h is negative, then I can use this first equation, because that's where the 1 plus h is less than 1.
So we have to try out both cases.
Yes. So that's what I was saying. We have to compute 2 different limits here, limit from the left and the limit from the right. So when your a is 1. And again, you see my graph here? It's just because at 1, here at 1, you have like green graph coming from the left and a red graph coming from the right. So it's like 2 different equations. So it depends where, if your h is negative or h is positive. But for example, if you take a different value, like here at 2 or here at -5, for example, here at -5, you see here from the left and from the right, it's the same graph, it's the same equation, right? It's the green graph, it's the same thing. Anyway, guys, I'm really sorry I went really over time. I guess I'm gonna stop here. Um, and I would probably come back to this example next time. Anyway, I guess there are so many people, they missed the lecture today, so I need to explain. Go over this example again next time anyway, right? So So yeah, I'm gonna stop here for today, and you know, I will see you tomorrow at 6, right? Unless there's a question or any requests or. Okay, so yeah, so let's stop here, guys. I will come back to this example tomorrow. All right, and we'll continue with this derivative thing. All right. Well, so good night, guys, and I will see you tomorrow. Right.
Thank you. Have a good night, Pastor.
Thank you, Professor.
Thank you, guys. Good night. See you
Good
tomorrow.
night.
Good night. Thanks.